Welcome to May's Leetcode Challenge. Today's problem is valid perfect square. I actually made a video for this a couple days ago, but unfortunately forgot to plug in my microphone, so I'll be doing it again. So here's the problem. Given a positive integer num, write a function which returns true if num is a perfect square. And all that means for it to be a perfect square is if the square root of that number is an integer. So say that we've been given the number 16, square root of that is 4, that's an integer, so we'll return true, it's a perfect square. Otherwise, if we were given a number like 14, there might be a square root number, but that's not going to be an integer, so we'll return false. So straightforward approach to that is basically iterate down a list from range of 1 to the number that we're given, so a list of integers incremented by 1, and we'll just square that number and check to see if it equals the number given to us, our input. And if it does, we can return a true. Otherwise, if we're able to go through the entire list, we can return a false. But we could quicken the process a little bit by doing a while loop. So every time we check an integer, we can just square that, check to see if it's greater than the number given to us, the number that we're checking for. And as soon as that number, the squared value is greater than the number given to us, we could break the loop and return a false. So all I did was start with an index number of 1 and a squared value that we're going to check for. So we'll start with 1 and start with something like squared equals 0. So while the squared value is less than the number we're checking for, we're going to first calculate our squared value. So that's just I times itself, that's exponent of 2, and check if squared equals num, return true. Otherwise, we'll increment our index number by 1 and continue the loop. If we're able to break this loop, then we can go ahead and return a false. So let me just make sure that it's accepted. So that does get it accepted, and that surprised me because it's so straightforward. I thought that they would probably look for a better solution because technically this is a big O of n solution. That's a very worst case scenario, but even so, it was too straightforward for me. What I thought initially probably was my approach, you could do some sort of binary search instead, because we already know we're going to be checking a list of integers from 1 to whatever input value we've been given. And if so, we can at least do this in log n squared time, or log n, big O of log n time, by doing a binary search. So what you could do is start with left and right values. L and num would just be our right value. And we don't need to actually create a list of anything. We're just assuming that they're kind of like visualizing one and just doing a typical binary search. So while left is less or equal to r, we'll just calculate a mid value. So that's what, L plus R, right, divided by 2. And all we need to do here is first find our squared value, which would be mid times itself, and check. Okay, if num equals squared, return true. Else if num is, or squared I should say rather, is less than num, then we want to search our the right side of this list, this imaginary list. So left will equal mid, and we can say -1 here. And otherwise, we know that squared is going to be greater than num. So if that's the case, we want to search our left side. So r equals mid plus, or I'm sorry, -1. Kind of got messed up here, +1 like that. And if we have to break this loop, that means this number doesn't exist, so we can go ahead and return a false. So let's see if that also works. Okay, great. So this is a big O of log n solution, and there are other ways to solve this. You can use like bitwise, you can use some obscure mathematical formulas. I saw one about Newton's method, but I don't think those are really necessary for like an interview. This would probably suffice. In fact, the first one itself is probably enough for like a phone screen. But that's how I solved it. So thank you.